Hello everyone, welcome back to Explore Electronics. In this video, let's see the instructions of 8051 microcontroller and let us look into each and every instructions with examples. The first one I am taking here is data transfer instructions. These data transfer instructions are going to be used to transfer the data from one register to other register or one memory location to other memory location. Suppose if we have a data 10 over here in R0 and in R1 we need this 10. So then we are going to use move instruction to transfer this data to other register like this. So if you look at the opcode here, MOV is the opcode we are going to use. With MOV we need to use the destination first comma source. Means if you are going to write move A comma RN, whatever the content present in RN will be moved to the register A. It means we are moving the content of Rn to the accumulator. It just copies the value present in Rn, and after the move instruction is executed, you will get the content of Rn in A. Rn will be there as it is, just we are copying that to the destination. After executing this, you need to observe here, no flags are going to be affected unless we are using or moving a value into the carry bit. Then only the PSW register is going to be affected. Similarly, any instruction which is moving a value into the PSW register means we know that there are different flags present in the PSW register. If we are using this PSW register in our move instruction, then only the flags are going to be affected. Otherwise, no PSW register is going to be updated with any flag. This is move instruction. Similarly, we have move with C. Here C indicating a code memory, or we need to access a code memory content or program memory, what we call program or code memory you say. In such case we need to use Movc. Here also Movc destination comma source we are going to write. Here the source will be always a register with accumulator value. Means at the rate A, in the sense what? A will be having some value. This value, whatever it is there in A register, will be an address. That is what at the rate means. Within that address, suppose this address will be located somewhere here. Within this we will be having a value. This value is specified with at the rate A. Within that we will be having a value, that is address. This address is pointing to the memory location like that. Similarly, in Movc, this at the rate A plus register what we have here is specifying to the code memory or the program memory. In this case, the register should be a DPTR register or program counter register. This is the rule we need to follow when we are using Movc. What happens when Movc is used? It moves a byte from the code memory into the accumulator. Why into the accumulator? Here the destination is accumulator. That's why we are saying it is going to move a byte of data into the accumulator register, and this indicating a address of the code memory. This complete indicating address of the program memory. By using DPTR you can see this is the example. By using program counter, this is the example. Suppose if you are going to use the program counter, what happens? In case of program counter first incremented by 1 before being summed with the accumulator. Before A plus PC is going to happen, program counter value will be incremented by 1. Then we have similarly Movx. Here X indicating external memory, external RAM we can say. In the previous case, C indicating code memory or program memory, that means ROM. Here X indicating external RAM. In this case also Movx is used with operand 1 comma operand 2, means this is the destination comma source we can say. This Movx is going to be used with DPTR register. Otherwise we can use R0, R1 also. So there are two cases here. If operand 1 is DPTR, we need to observe what happens. If operand 1 is R0 or R1, we need to observe what happens. Operand 1 in the sense when the destination is DPTR, then what happens? The accumulator is moved to 16-bit external memory address indicated by the DPTR. The instruction uses P0 port and P2 port. Why P0 and P2 ports are indicated here means These two ports are going to be used for accessing the external memory connected. External memory is connected external to the microcontroller. This side will be having a microcontroller. Through ports we have connected to the external RAM. We can say this is external RAM. So here port 0, port 2 is going to be used when we are using with the DPTR, since it is having a 16-bit address. And the example is Movx at DPTR comma A. In this case, accumulator value we are putting to the external memory. This is from microcontroller to the external RAM, we can say RAM. Similarly, move A comma at DPTR. Here at DPTR specifying the address of the external memory. From the external memory, this is external memory, to the microcontroller we are moving. Within the microcontroller we will be having register A. To the register A we are copying. Here DPTR is going to hold that address. Similarly, if the operand 1 is R0 or R1, then what happens? Here you can observe Movx at the rate R0 comma A. Here we are taking A value. A value will be a 8-bit value. We need to put that into the address specified by R0. Here R0 is specifying the address of this instruction uses port 0. Using port 0, we are going to send the 8-bit address and the data. Here port 2 is not going to be used. Since R0 is also a 8-bit register, here we are specifying only 8-bit of address. Since 8-bit of address is sufficient, port 2 is not supposed to be used, only port 0 is sufficient. Similarly, when we are extracting the data from the external memory to the microcontroller, means to the accumulator register, then also we are going to use port 0 only. When we are using DPTR, port 0 as well as port 2 comes into picture. Then swap instruction. Swap instruction is that it is going to swap the two nibbles. Means if you have A and 7, or we can say okay A and 7. So this and this is going to be swapped after this swap A is going to be executed. This register A will be having A7 previously. After swap A is going to be executed, it becomes 7A. That is how swap instruction is going to be used. The same thing can be done using rotate right A, rotate left A. Means accumulator register is used here also, and swapping can be done using 4 times rotate. Means 1100 0010 is something like this. We need to swap these two values present in the accumulator. What we can do? We can rotate this 4 times, 1 bit, 4 times, then completely it shifted over here, right? Similarly, using right or left shift. Swap is going to do the same operation which RL and RR takes 4 times. Exchange instruction, that is XCH. Exchange A comma register. Means A will be having a content and some register R0 will be having some other content. We need to exchange these two values. We need to copy A to R0, R0 to A. Then we are going to use this exchange instruction XCH. Then we have push and pop instructions. These two are going to be used with a stack pointer. The stack pointer is going to indicate the memory location where it is pointing, and the push instruction is going to be executed. It increments the value of the stack pointer by 1. Remember, when push is going to be executed, it increments the value of the stack pointer by 1, and then we are going to store that value in the address which is specified over here. Similarly, pop instruction is going to be used to take out the data which is pushed last, right? So here pop instruction, what it is going to do? It is going to decrement the stack pointer by 1. First it is going to decrement, and then whatever the location stack pointer is going to point out, we are going to take out the data. So let us understand this push and pop instruction in other video in detail. These are very important for exam. So remember, here push instruction used stack pointer, pop instruction also used stack pointer, and we are going to take the data from the internal RAM and we are going to put into the internal RAM. So that is the case where push and pop instructions are going to be used. Then arithmetic instructions. Arithmetic instructions in the sense addition, subtraction, multiplication and division we are supposed to do in microcontroller using these. ADD is the instruction which is used for addition. Add A comma R1. If you are going to execute this instruction, what it is going to do, it will add A with R1 content, and the result will be stored in A register itself. The content of A and content of R1 is going to be added. The result will be stored in the accumulator again. And here you can observe add C is there. This extra C is required when we are going to add the carry flag bit also. Means here A and A will be added with 2. Content of A will be added with value 2 plus carry flag will be considered. Then the result will again go back to the accumulator again. With carry, where we are going to get the carry in the carry flag in the PSW register. SUBB, this is for subtraction. Subtract from accumulator with borrow. Again, we are considering borrow in the sense that is a carry bit of PSW register itself. SUBB A comma R2. This subtract the content of R2 from accumulator. It means A minus R2 is the thing we are going to do, and the result will again be stored in register A itself. Then multiply instruction, that is MUL AB. Here this will multiply the content of A with content of B. This is also an 8-bit register. This is also an 8-bit value it is consisting of. You know that the 8-bit into 8-bit, if you are going to multiply, we are going to get 16 bits. So this 16-bit is going to be the result. We can't accommodate into A or only into B. That's why the first half of, or the least significant bit, we can say, out of 16 bits, if we divide, it is 8-bit plus 8-bit. The lower 8-bit will resides in register A. Upper 8-bit or the most significant byte will be resides in B register. And here the carry flag will be cleared. Then division instruction. Similarly, here division is used as we seen here in multiplication. Divide AB. This divides accumulator to the B register. This is unsigned division. Accumulator is divided by B register. It is like A divided by B. Here we are going to get the quotient as well as the remainder. Quotient will be placed in accumulator register as a result. Remainder will be placed in B register as a result. Similarly, in multiply instruction, where the lower 8-bit will be in accumulator register, upper 8-bit will be in B register. Similarly, here quotient will be in A register, remainder will be in B register. Here also carry flag will be cleared after this instruction is executed. Then we have increment, opcode INC with a register we can use. If A will be containing a value like something like 7, if we are going to use INC A, what it is going to do? 7 plus 1 it will perform, and A value becomes 8. This is what the increment. This increment the value of the register by 1. What happens if this A consisting of maximum value 255? If the maximum value, 255 means it is FF in hexadecimal. If the maximum value is contained in the register A, plus 1 if you do, it becomes 256. But we can't accommodate within 8-bit register. So in that case, if we add 1, it will roll back to 0. So similarly, you can see if you use increment DPTR, the maximum value DPTR can hold is FFFF, or we can say in decimal it is 65535. If you are going to increment DPTR when DPTR contains the maximum value, again it will roll back to 0. And here the carry flag is not set when the value rolls over. This might be you are feeling like plus 1 we are doing and carry will be generated here. So we need to set the carry flag. No, it is not the case. Carry flag will not be affected over here when we are rolling off from 255 to 0. Similarly, when DPTR rolls over from 65535 to 0, no carry flag will be set. Then we have decrement register. Similarly, as we have increment, here we can do -1 also using decrement with a value register. Decrement with a register specification. Here also it will subtract 1 from the value present in the register if it is 0. If the register is containing a 0, we are supposed to do 0 minus 1. In this case, you might be expecting some negative value. That is not the result, but here it will be roll over to 255, the maximum value. And here also carry flag will not be affected. So these are the different instructions we are going to use in microcontroller coding. In the next videos, let us see more concepts on this microcontroller. Thank you.